Hello.
Gonna get a blinky, but then people start showing up.
So far we have Ben and
Hello.
Hello. We'll get started in just a few moments. If you guys can mute your mics, we'll call on you.
Yeah. That's cool. That's fast. We already have 2 people.
Yeah.
Okay, I'm excited. All right, shall we begin?
Yeah. Let's give everybody just like one more minute or so.
Is it a minute yet?
If we only had electronic clocks that we could.
Oh, you know what? We should actually have the big digit Ethernet science clock out here all the time. That'd be cool.
Let's see. Is it? Air call. This is going to be an awesome show.
Oh my God! I see Blinky.
Yeah.
It's full of Blinky.
This is great. All right, everyone. We're going to get started in a few moments. Mute your mics, and we'll call on you.
Okay. Rock on.
Yeah, let's get this going. Okay.
On the road.
Ben, you were first in here. Ben?
Hi.
Bing.
How's it going?
Hi. I don't know how this works. Sorry, I'm new to this.
That's okay.
So are we. It's only like a week old.
All right. What am I supposed to do? Show you my thing.
Yeah.
I should show you the problem first, otherwise you don't understand what it means. I got into electronics only a year or 2 ago because, you know, like a lot of folks, I grew up with computers and came to electronics late, and I discovered I got tired of soldering blinky things, and
What?
I know, it's sad, I know. I got sucked into ham radio. I said, oh, this is a great outlet because you still get to like build cool electronics, but in the end you get to essentially get on the airwaves and brag about it.
That's even more expensive than Blinky stuff.
Even more expensive, exactly. So I have a mentor, a good buddy of mine, who's actually much more versed in double E than I am. And so part of doing Morse code is what you do is, well, we do a lot of Morse code in ham radio. And usually what you do, I'm going to switch I'm here in my basement lair. What you normally use is something called a keyer to generate Morse code with a pair of paddles. I don't know if you can see this. This thing's called the keyer, sort of a big blocky device, and this thing sends Morse code.
That's a nice keyer. It's like brass and wood. It's very steampunk.
Well, this is these are the paddles, and this is the keyer, right? Yeah, this is I put the nice wooden paddles on, right? So here's the thing, you know. You use these to generate perfectly timed Morse code, and there's a nice CPU in here, and what you do is, you know, if you want to send a hail in a loop for 20 minutes, instead of doing it yourself, you have this little device do it for you, right? And you can change the speed. There's CQ, right? All right, I can shut it up. So here's the problem. I like to go out in the field. And take this little tiny radio with me and like set up an antenna and a park bench and like talk to people with Morse code. The problem is my little tiny radio doesn't have any of these devices, and I don't want to carry this big blocky computer with me to just auto-play Morse code. So I said, this is crazy. I've got this smartphone in my pocket. It's just an Android phone, and I said, you know, here's a chance to, you know, write an Android app that generates Morse code. And so it's an excuse to learn Android. And you can see this is basically does the same thing. You type, it's hard to see, you type a little phrase on your Android phone, and then you hit play, doing the same thing as the box. I'm like, all right, I'm halfway there. I've got a smart computer. I type it. It plays Morse code for me. Now here's the problem. How do I get my radio to hear that and actually transmit Morse code? And the problem is a radio expects you to have a telegraph key attached. It sends out a current out of a circuit. And if the current comes back, if it's a closed circuit, it says, oh, you must have the telegraph key down. I'll send a tone. Right?
Oh, do you use UTMF decoder? That would be so awesome.
It could generate UTMF. No, it's not that. We just said, all right, we need to design some kind of circuit that converts sound coming out of a phone into tricking a radio into thinking you're pushing a telegraph key, that you're closing a circuit.
Yeah.
So my mentor came up with some interesting designs where, you know, it had some 9-volt batteries and a couple of op amps, and it was very complicated. Ultimately, he came up with a much simpler design, which we tested on a proto board, just a regular breadboard solder, and it worked. Essentially, we said, all right, we've got half a volt of AC.
Oh. Hello? What happened?
Everybody else is still here. Ben's gone.
Darn it.
Oh, no, you're back.
Oh, you guys are still here?
We had a thing. So we're back. Okay, so you got a breadboard with the switch on it.
Yeah, so here's the deal. So coming out of the phone, you got half a volt of AC.
Yeah.
I mean, that's the sine wave coming out. So we send it into and if you can see this, this is the little thing I built. This is the perma proto board, which I bought from you guys, which is awesome. I love it.
I like the
I could just
box. Yeah, it's nice.
I put it in a little box. So what happens is you take half a volt AC coming out of the phone, you send it to a transformer. All these parts are from Radio Shack, into a generic audio transformer that sends it up to about 10 volts, about 5 volts AC. Then we send it into a full wave rectifier, which converts it to about 3.5 volts of DC. And then from there, we take that and we send it through through resistor, so it's about 0.7 volts DC, and we use that to tickle the base of a transistor. And that transistor then acts as my fake telegraph key, right? Because on the other side, I have a loop with the transistor being the switch, right? Yeah. So every time sound comes in, it closes the transistor.
That's awesome.
That's it. So let me demo it here. I'm going to hook it up and move the camera over.
Yeah.
So yeah, hold on a sec here. This goes into the radio, so plug. And then of course I went to the hacker space in Chicago here, and we drilled cute little holes in the side of the box, so you guys can see. I'm going to hold this over here. Hooked up now. Let's see. Does this work?
Yeah.
Oh, it looks really big. Sorry. How about that?
Mm-hmm.
Yeah.
Mm-hmm.
Still there. Still there.
Yeah.
Yep.
Little battery. Oh no. You went slow. I think it's our internet.
Nope.
No?
Anyone? Oh, sorry. I lost you guys. Sorry.
Yeah, we're still.
So, good. So, here's the box. I've got the cute little one side going to the phone, one side going to the radio, and now I'm going to plug it into the phone. Hold on here. See if we can do a demo. If I can hold it still. So the radio's on the bottom. This is a watt meter going into a dummy load, so I don't, just to prove that it's transmitting. And I'm going to try it out here now. Turn on the radio, and I can play. I don't know if you guys can see.
Yeah.
There's the watt meter going.
Yeah.
So whatever I type on the phone, it actually gets transmitted now. It's pretty cool.
And if people want to communicate with you, what's your call sign?
NN9S.
Okay.
Excellent.
So yeah, the source code for the app is on Google Code, and we're going to put up, I don't know, I think we actually may want to make some stickers or do something like make a circuit board for others to share.
Yeah, totally.
Make a PCB or something.
And post up in the comment area on Lamore's show and tell link. I think you already did. And we'll do a post up on Adafruit. That'll be really neat if we can have phones talking to phones over
yeah.
Over the radio?
Phones talking to him radio.
From a proto powered.
Word.
Yeah. Anyway, my first experience with the proto board, it was awesome. Thank you. It made it so much easier because I had never really, I'm new to this, right? I've only ever used solderless breadboards, and my mentor was busy taking real perf board and prototyping stuff.
Forever. You're bending and then it falls apart. I hate that stuff.
Yeah, it's hard. This is great. This is awesome. It's so pretty. So here it is again for everyone to see in this little box.
You did a good job. I like the bumpers. I'm really into bumpers.
Yeah, it's I think it's like a little dice box,
Yeah. Yeah. I was nobody uses dice anymore, so it's okay.
Exactly. Thank you guys.
All right.
Thank you so much, Ben. Very cool project.
Yeah.
All right, next up, Eric Hall. Unmute your mic. This looks like something really neat.
There's a lot of stuff going on there.
Eric Hall.
Yes. Down, I think.
Do we have voice?
Hello.
Yes.
All right, good.
Is this CERN? Are you finding
I see a
the Higgs
petabyte.
particle?
What is that there on the right? It's like a chicken.
There's a lot of stuff, but I have a pointer to
Oh, great. Yeah. All right.
Okay.
Show us your project.
Lately I've been playing around with different platforms, different microcontrollers, and getting them to talk to each other over a variety of different protocols. But GHI, I'm a Microsoft guy, and do a lot of NetMF programming. But GHI has just come out with this new Gadgeteer board that's all open source. Called the Hydra.
And then also the Netduino. There's a lot of stuff going on in the .NET world. It's kind of exciting with
it's great.
Stuff. Yeah.
That's what I do for a profession, so just switching over to this was no learning curve on the code. It was awesome.
Yeah.
The cool part is this thing will, all these little can you see my little pointer? There's my little pointer.
Yeah, yeah, we can see it.
All these little sockets are all 10 pin, and they all support different protocols. So all we need to do is take these ribbon cables and break them out on a prototype board.
Oh yeah.
You'll recognize some of your stuff on this side.
Yeah. That's my side.
Yes, exactly. I got a little Arduino there where I prototype stuff. And I started with the Arduino because I was already familiar with it, and I had a few. And now I've got it down just to the Atmega chip and a clock. This particular one is very simple piezo talking serially back and forth. The neat part is it's using an old Nokia ringtone format, so it's basically text, essentially. Yeah. That you type in your song in text on the NetMF side, send it serially over to the Arduino, which then uses the tone library to spit it out the piezo. And about all I got an annoying little bumper actually I used to keep it quiet. Because after
being really loud.
Yeah, after about the 50th version of this, I put the bumper back on.
Yeah. Okay, there you go. Got it. Toning.
Yeah, but this is a really slick way to quickly prototype some modules for the Gadgeteer platform. And there's a little spot on here. I've got a little AT-Tiny 85, and I'm having a blast with it. It's
awesome.
Yeah.
Yeah, this is great. I like that it's just like this menagerie of microcontrollers and platforms, and they can all talk to each other.
Yeah, and nope, there we go. Now we'll silence the thing.
The last
yeah, it goes on forever.
Cool.
It's fun. Yeah, everything is open. It's awesome.
Yeah.
Very cool. Well, as you keep doing this stuff, feel free to post up some links and some photos. I'd love to have like a photo of all these different dev boards talking to each other, because if dev boards can get along, everybody can get along.
Yeah, true.
Yeah, my eventual goal is to use the Gadgeteer as sort of the controller for some home automation and just get rid of the wires and go XP and stick the little chips in, doing their thing in various corners of the house, and use this to keep track of all of it. Yeah,
check out Chris Courtwright's his XP protocol thing that he made for managing this horse network.
I actually looked at his, and there's some nice Java code on Google as well for the XP stuff. Yeah.
All right. Well, thank you so much, Eric. Did you have blinky suspenders when you first got on? Was that
once I go silent, I will go back to the picture of the blinky. No, this is the latest in Lab Science Geek. I have some of your patches and one of the LED strips. And
at the end of the show and tell, we will come back to it. We would like to see that.
Okay, so all right.
Okay. All right. Well, thank you so much, Eric. Next up,
sure.
Jason Webb. Jason, show us your project.
Hey, can you hear me all right?
Yes, we can hear you perfectly.
All right. Well, back in October, I worked with an art professor at my local university to create kind of a pseudo art show, use his skills with my understanding, I guess, of undergraduate level engineering. So I have a degree in computer science and physics, but not a lot of opportunities to apply them in interesting ways, especially in a small town. So I just got to work making a whole bunch of little things and trying to learn the next steps of Arduino and, all the fun things that I haven't had a chance to do at that point. So what I'm going to show off is a batch of little synthesizers that I made. That there's 5 of them in total, and let me get these close to the camera. These were hanging from these power cords from anchor wire, kind of in a little a mobile, like a kinetic sculpture kind of a thing.
Yeah.
So these things were getting some power, and it's an Atmega chip you can see on there.
Yeah.
And the entire thing is based on a abandonware synthesizer called Arduino. It's like a two-channel granular synthesizer. Mm-hmm. So I had to learn a lot about what the heck those terms mean. But I learned enough to just get the Atmega chip running, the programs burnt onto the chips, and I attached distance sensors, little infrared distance sensors, to the bottoms of each one. So we've got a main board with some dials to adjust the tone, speaker, and a distance sensor. So these were hanging at about human, chest level. So people could walk into the space and just kind of circle this mobile of synthesizers. And each one was tweaked to make a slightly different, really annoying noise. So we drove the secretaries nuts, but it was totally worth it. So over here, I've got a little demo going. And we'll see if the sound picks up well.
Yeah.
If not, just let me know.
Oh, yeah.
Oh yeah, that's definitely annoying.
Yes. And so you can tweak the little potentiometers on here to make tons of equally annoying sounds. And it just goes on forever. So these distance sensors are kind of medium range, I think, about 6 feet. So they all kind of make a weird noise in that, 3 feet and less distance. But you can hear it kind of doing some weird noises. So what's really cool is the Arduino framework. It quantizes the analog read signals into notes on the pentatonic scale. So no matter what tone you're hearing, it's always one of those nice sounding notes.
Oh, okay.
So a fun side effect was that when there were 5 of these things going, it actually sounded kind of nice because it was like a 5-note chord playing all
they're all
the time.
playing in tune, essentially.
Yeah.
So it was really unusual, but people didn't know what to make of it because it's a little circuit board. It's not, dressed up with ceramics or things that they can identify with.
Yeah.
But the noise, I think, made it pretty obvious what it was.
All right.
That's art.
Well, very cool, Jason. Thank you for sharing this. If you have any links to the project or anything, put it up
Or
in
the
the
Arduino thing.
comments.
Yeah, all the source code and all the PCB files that I made, I'll put them in the chat.
Awesome.
Okay, we're going to try to get through 3
We have-
people
oh, yeah, we have
in 10
10
minutes. We got 3 more. Well, thank you so
Okay.
much, Jason. We're going to move on.
Next up,
Let's see. Can you read this one?
Michael.
Yeah,
Mikhail.
Mikhail?
Mikhail.
Mikhail.
Yeah, that's me. It's Michael, actually.
Okay, Michael. Great.
Okay.
Can we great?
Yeah. We're going to try to have you show your project, and then Steven, and then maybe Bob at the end. So you've got...
Okay, mine is really short. So, by the way, I'm from Poland, and it's like 4 a.m. here.
Whoa.
Thank you for getting up early or staying late. One of the two.
I'm an engineer. I'm used to staying up late. So basically, I'm into Blinky stuff because I'm only starting out with AVRs and electronics and all that. So I wanted to finally make my first PCB design, and they made it for me at my university. I don't know if you can see it.
Oh yeah, look at that.
I'm confused.
Yeah,
It's a circular. It's actually an LED necklace.
Okay, great.
It's got 10 LEDs along the circle, just a button, a battery in the back, and you just press it, and
Whoa.
it does.
Yeah. That's nice.
Yeah, I don't know if you can see. It makes circles.
Yeah, it's spinning.
Yeah, and you get to wear it. Well, we're really into round circuit boards and wearing electronics, so this is really nice.
Yeah,
That's a nice.
yeah.
way
I wanted something I can wear and show to people. And basically, this is version 1.0. I'm planning version 2.0, which would have a temperature sensor, and according to the temperature, it either spins faster or slower. So it's kind of like a walking thermometer.
Yeah, people know what the temperature is as you're walking down the street. They could just look.
Yeah, they know if it's snowing.
They'll stare at you.
Well, post up any photos or anything in the comments, and we'll do a blog post on it. This is a really cool looking project. I like wearable stuff, obviously. So.
Yeah.
I want to do more of this stuff, like earrings maybe.
Yeah.
Earrings is a cool
You
idea.
can look at the iNecklace circuit board and base it off of that. We want someone to make earrings.
Oh yeah, I saw it. Yeah.
Yeah.
Okay, I'll look at it. I also have one, also a very short project I just wanted to show. It's a spinning display.
Oh, look at that. Oh, cute.
Yeah.
Project.
I made it at a summer school course once. It's the fish.
The
I don't know
fish.
if you can see.
Yeah.
It's hard to see, but there's a fish. Yeah.
Oh, yeah.
That's it.
Orange fish.
And it just goes around and around in circles.
That's great.
Just like a real goldfish.
Yeah, basically, This course was very cool. You can make any animation with 8 RGB LEDs. It just spins with a DC modeler inside. At
Wow.
Mega 64.
Those are 2 excellent first projects. I can't wait to see what you do next. This is gonna be
Okay,
cool.
thanks. That's
Nice work.
Next
very
week
nice.
we'll be covered in LEDs, like Eric is
Blink,
over there. We'll get
Blinky stuff is awesome, right?
Okay.
All right, bye, Michael.
Okay, see ya.
All
See ya.
right. What's up, Steven? Show us your project.
Okay, so I have one of your it's a joystick,
Oh yeah.
Yeah.
and I put in a big wooden box,
Wooden box.
and I got some buttons from eBay. They have RGB LEDs in them,
Oh,
Yeah.
nice.
and they can fade and stuff. And I'm trying to get if you can see the ball top is clear.
Yeah.
I knocked it out with a different one, and I'm trying to get a shaft that can light up.
Yeah.
That's tough.
And on the I basically took apart a Xbox controller
Uh-huh.
and soldered wires to it,
Sweet.
and that is a project for one of my one of my fundraisers on Indiegogo called Hackman.
Oh, cool.
Sweet.
Yeah, and the Hackman is basically like you can insert your own characters into a Pac-Man game and edit it.
Oh, wow.
It helps you learn how to go around, and that's about it.
Sweet.
Oh, excellent.
Nice.
Thank you so much, Steve. If you want, post up links to any of this, including your Indiegogo on Lemore's comment area. Maybe that'll help get some more funding for it too.
Yeah.
Sure.
I like joystick controllers. They're one of the first projects
Yeah.
that people build because it's like you use it. It's like very
It's
gratifying.
fun.
Okay,
All right.
great.
Thank you so much. And last up tonight, Bob, show us what you got. This looks amazing.
He's got like a
I see
Nixie's,
Nixie. Yeah.
and he's got
Saturday.
Saturday.
Can you hear me?
Yeah.
Hello. Hello.
Hello.
Thank you
Oh, wait,
for
you have
inviting me on Invention Exchange. So I'm Bob, and I've been doing Dixie Tube clocks for a while, cogwheelcircuitworks.com.
Oh, look at that.
And
That's a blue one, yeah.
mostly I build these boards which have a very small market to people who have already got these big tubes, which are
Yeah.
very hard to find on eBay. And I'm about to release a little Nixie shield, which will allow people to just go out on eBay, find the tubes, a variety of tubes, not just this model, but there'll be a couple of different boards that'll go onto this, which will allow you to go out on eBay, find whatever you can get, and then light up your tubes.
Yep.
So so this should be available in the next 90 days, and it's all surface mount, and it comes with lots of software. It uses the same software as my as this one back here, and there's yet another model which is on the website cogwheelcircuitworks.com, and so people can have fun with it, and it's all open source. But I've got another thing I want to show you really quick, 30 seconds.
Yeah.
If you asked me a couple of weeks ago, I would have said, don't ask, I can't tell you yet.
Yeah. Yeah. We know that segment.
But I decided that I got tired with the Nixie tubes running out of at mega memory at 32 KB, and I thought, what if I had Linux and 64 megs of memory? And so I started to build and am going to release a board which is Arduino form factor, Arduino compatible. It's the IMX233 Freescale processor. It's the same processor that the Trumby uses.
Yeah, I was going to say it's Trumby.
And it'll be all open sourced, and it'll have you'll be able to plug an Arduino shield on one side and an LCD touch panel on the other side, and it should be lots of fun. And I think that it's going to capture a lot of hearts and minds, because you'll be able to download prepackaged binaries of the Debian ARM release, and it'll have an Ethernet interface, and you'll be able to run your own, hopefully, your own development environment on a board which can take a shield. So.
Very cool. Did you look at Bunny's files and his open source work to help your design, or did you just do it straight up from scratch?
Oh no, I'm very thankful for Bunny's project, and there was a couple of other projects that used the IMX233. They were all open sourced, and they were very helpful. And
That's great.
The part's very inexpensive. So the cool thing about this will be way less than $100.
Yeah.
And,
Very cool.
Great.
Anyway, I'll post a link.
Yeah,
Excellent.
please do. Thanks, Bob. I can't wait to. I like the Chumby like mini Linux computer. I think that's where it's heading. So this is fantastic. Like BeagleBone is kind of getting there.
Yeah.
Chumby Hacker Board, and now this is really exciting.
The nice thing about the Chumby stuff is because they did so much work on getting Wi-Fi working,
Yeah.
and like all the file system stuff that it's very easy to just grab the distro and it runs.
Yeah, and everyone knows Linux, so you gotta
Linux,
know what's there. All right, we're gonna stop in and see Eric who's blinking.
Okay.
Thank you, everyone. That was a fantastic show and tell.
Let's finish up.
All right, Eric. Everything's blinking.
This is crazy.
Whoa.
All right. Oh wow.
There we go. No, this is just a regular old lab coat. Couple of your patches. The inside. Da-da-na-na. The inside is LED strip. These are WS2801s.
Yep.
This is one of the Fez Pandas, because I'm a NetF guy.
Yeah. Gotta represent.
Exactly. It's underrepresented. The battery pack is kind of hefty. I used this over the 4th of July and did some red, white, and blue stuff. So I've got a big honkin' 6-volt lantern battery, but I have run it for 30, 40 minutes on a little LiPo. So I think maybe 2 amp hour LiPo, maybe something like that.
All right.
So it goes quite a while.
Yeah.
And actually, this particular strip doesn't have a lot of room to sew on, which is kind of why I did the under the.
Yeah.
That I didn't really want to sew into it.
We'll have something very sewable and very blinky soon too. So you may have a lab coat upgrade, and it'll probably work with everything you're already using right now.
Yeah.
I'm slathering over the floor already.
Yeah.
Okay. We'll have more about that later.
Okay, great.
Okay, everyone. Thank you so much. That was a fantastic show and tell.
That was crazy.
Okay. Bye bye, everybody.
All right. See you guys soon.
Woo.